Welcome to Architecting Test Systems using Teststand, the second course of 2 self-paced online trainings for NI Teststand. In this course, we will look at different components of the Teststand framework and determine when and how to modify them. During this course, we will work with the Architecting Test Systems using Teststand exercise guide, as well as the exercises and solution folders, which you should download as a zip file. To get started, make sure you have all of the following items: a computer running Windows 7 or later, Teststand 2017 SP1 32-bit, LabVIEW 2018 32-bit, and/or Lab Windows CVI 2017. If you choose to complete the course exercises using Lab Windows CVI, you will need the LabVIEW runtime engine to complete some of the exercises. We recommend copying the exercises and solution folders to a directory that can be easily navigated to and accessed. For example, exercise files in the C Exercises Architecting Test Systems folder and solution files in the C Solutions Architecting Test Systems folder. Each lesson of the Architecting Test Systems using Teststand course contains the following: an introduction with the lesson objective and a list of topics, slide images with additional descriptions of topics, activities, demonstrations, and multimedia segments, exercises to reinforce topics. Some lessons include optional and challenge exercises, and a lesson review that tests and reinforces important concepts and skills taught in the lesson. To get the most out of this course, we recommend you to take full advantage of the exercises guide, exercises, and solutions provided. Take your time on the exercises, making sure that you have time to complete each step. Explore solutions to gain a deeper understanding of the concepts behind each exercise, and keep in mind that the solutions provide one possible approach, and you may find a better one. National Instruments offers certification to gauge proficiency and understanding of Teststand. The CTD covers concepts introduced in the Developing Test Programs using Teststand course, and the CTA covers concepts introduced in the Architecting Test Systems using Teststand course. National Instruments also offers badge assessments to help you gauge your understanding of test fundamentals and best practices using Teststand. This course prepares you to identify the different components of the Teststand framework and determine when and how to modify them in a manner that follows Teststand best practices. This slide outlines the course learning map for this course. We'll begin by discussing assigning development tasks and work our way up to managing a Teststand deployment. Welcome to Lesson 1, Assigning Development Tasks. The objective of this lesson is to determine which development decisions should be made by sequence developers versus framework architects. The Architecting Test Systems using Teststand course builds on the foundations taught in developing test programs using Teststand to help framework architects create custom frameworks. The objective of this section is to review the responsibilities of a sequence developer. Executing test, responding to instructions in the test. There are 4 main testing roles that we will be referring to. The operator is responsible for executing test, responding to instructions in the test program, and performing any portions of the test that require human interaction. They generally need minimal technical understanding of the test system or the UUT. The technician is responsible for analyzing the devices or products that fail tests and diagnosing the issues that are causing the device or products to fail. They need extensive knowledge of the UUT, and they must be able to analyze the test program to isolate the reasons for failure. The test developer writes test programs for individual devices. They create the code to test individual aspects or components of a device, and the logic to combine and sequence those individual elements into a cohesive test program. They must have the technical ability to create test programs and write test modules in one or more development languages, and they need enough understanding of the UUT to write code to test the device requirements. They must understand the test framework to write test programs that use the framework. The framework architect creates the test framework under which all test programs are executed. They must have extensive knowledge of the technology behind the test framework, enough proficiency in one or more development languages to write user interfaces and tools. They need knowledge of other technologies or applications, such as databases or analysis tools, and they need only minimal knowledge of the UUT because test developers will implement the device-specific code. For smaller organizations, one person may be required to satisfy multiple roles, but the distinguishment of these roles helps to plan for growth in a company. Looking back on the Teststand execution architecture, test sequence developers are responsible for 4 tasks. Number 1, creating test code for a specific UUT. We recommend using the client sequence file only for code that is specific to a particular type of UUT. Sequence files, sequences, and code modules can all refer to test code that is specific to one UUT. Number 2, overriding callbacks that are defined as part of the process model. A particular type of UUT might require an exception to the process model, and so you can override callbacks in the client sequence file to implement the new execution. Number 3, storing test program limits and local data in the client sequence file. You can manage test limits in several ways, and one acceptable technique is to include the test limits in the client sequence file and use the Teststand import and export properties tool to manage the test limits. Number 4, specifying error handling in the client sequence file. You can also use the client sequence file to store error handling code for specific error conditions that steps in the test program might return. As a test sequence developer, you must be aware that code developed for the client sequence is difficult to share or reuse, and too much code in the client sequence can clutter or obscure the test program. If the client sequence starts to contain too much code, you should start to consider updating the framework. The objective of this section is to review the responsibilities of a framework architect. You can use Teststand to modify almost every aspect of a test executive. Any given operation can be implemented in more than one place, such as in a client sequence file, a process model, a custom step type, or a custom user interface. The location of operations has significant effect on the flexibility and maintainability of the test system. Test framework architects must choose where to implement functionality. Much of the power of Teststand comes from the fact that Teststand is highly customizable. For a given operation, you might place the operation in a client sequence file, several places in the process model, the substeps of a custom step type, a custom user interface, a front-end callback, or a station callback. And the location you choose can have significant effect on how you implement the operation, what data the operation has available, the way the operation interacts with the operator, the reusability of the operation, and how difficult the operation is to modify and maintain. When looking at the Teststand execution architecture model, test framework architects are responsible for customizing the process model, which includes creating callbacks that test developers can override, test execution control, report generation, data logging, and communication, and also creating custom user interfaces, which includes an operator mode and possibly an editor mode. This course is about learning how to complete the responsibilities of a framework architect. You can break the responsibilities into 3 categories. Developing the test framework, which includes developing the user interface, UUT tracking, report customization and results logging, and creating a set of test system requirements separate from the test program requirements that describe, implement, test, and track test system requirements, like the requirements of any software product. Create development tools. It is also the responsibility of the test framework architect to create reusable components to enable developers to develop consistent sequences and code modules. Test building blocks assist the test developer or give them access to special features of the framework, such as custom step types, custom data types, and templates. Developer utilities, which assist in managing the framework or developing test programs. You are also responsible for managing code reviews. As the test framework architect, it is your responsibility to ensure that test developers follow the development guidelines that you have established. For example, did they use the tools that you have provided? Have they developed any code for their UUT sequences that should have been part of the framework? In Lesson 1, we learned about assigning development tasks. The test developer writes test programs for individual devices. This role requires knowledge of the UUT and understanding how to use the test framework. The framework architect creates the test framework under which all test programs are executed. This role requires extensive understanding of the technologies behind the framework, but only minimal knowledge of the UUTs themselves. Lesson 2. Developing multiple independent applications. The objective of this lesson is to create multiple independent test applications and configure them for deployment. Developing and executing multiple applications. First, we will discuss how you can create teststand environments for your different test applications. The objective of this section is to define the new environment to enable the creation and configuration of multiple test systems with unique configuration settings on a single development computer. The universal test system is used to test or run multiple applications at the same time or on a whim. For example, running my PMIC test and my RFIC test. In production, a single station may be used to test a variety of DUTs. During development, a test developer may want to work on two unrelated applications simultaneously. Creating a universal test bench is a way to reuse hardware when testing, take advantage of high bandwidth and channel counts. In addition, a universal test bench could also allow the simple sharing of framework components, such as process models and advanced architectures. The universal test system can be used to test different DUTs, potentially requiring use of entirely separate code bases and a unique hardware configuration per DUT. Other differences might include the user interacting with the tester, such as the test sequence developer during development and the operator at runtime. And another difference could be the output of the tester in terms of report format and location. Components and configuration settings can be defined locally. This does not need to include every setting of Teststand, but you can define the settings relevant to your application and leave the rest to a default global configuration. For example, an application requires an entirely separate language for operators, but uses the same process model logic to complete execution. You can load different custom types, step types, adapter settings for one application, but leave the font size and pane orientation consistent, etc. Or you can completely change all of those settings between applications. Teststand environments enable two or more Teststand configurations to exist side by side on a single system. Teststand environments are defined by an INI text file with the .tsenv extension. To define the environment, you need to define the following fields in the environment file. The common app data directory, which specifies the Teststand application data directory, which implicitly specifies the Teststand configuration directory, containing various Teststand configuration files. The local app data directory, which specifies the Teststand application data directory. This directory contains configuration files typically related to the layout and/or state of the sequence editor or Teststand user interfaces. And lastly, the public directory, which specifies the Teststand public directory, which can contain modifications and customizations to existing Teststand components, custom user components, and other Teststand-related files. There are two methods to create a Teststand environment. The first method is to create the file manually using a text editor. The second method is to use the Configure Environment dialog box available in the Teststand sequence editor under Configure Environment. Refer to the Defining an Environment topic in the NI Teststand help for more information on defining a Teststand environment. In this demonstration, we will create a Teststand environment and switch between different environments. In the Teststand sequence editor, navigate to Configure. Using Teststand environments can present limitations in the following scenarios. If the global environment has multi-byte strings enabled, then all environments must have multi-byte strings enabled. Environments do not support loading an alternate set of users and passwords that differ from the global environment. All environments use the users.ini file defined in the global environment. You can completely disable the environments feature by defining the registry keys. The Teststand remote engine does not support environments. The remote engine always runs in the global environment. Although it is possible to run two or more instances of the Teststand engine simultaneously in different environments, the instances are not completely isolated from each other. Certain features of Teststand are shared at runtime and could conflict, such as out-of-process synchronization objects, out-of-process executions for LabVIEW and CVI adapter steps, which will generally occur within a single shared instance of the external LabVIEW or CVI ADE, 64-bit Teststand applications configured to use the 32-bit National Instruments switch executive share a single instance of the out-of-process switch executive. 64-bit Teststand applications configured to run switch executive in process will not conflict, and 32-bit Teststand applications always run switch executive in process and therefore cannot conflict. When debugging, stepping into a code module from an adapter step can use an existing instance of the external ADE already in use when Teststand application is running in a different environment. Refer to the General Environment Limitations topic of the NI Teststand help for additional information about each of these limitations. You have the ability to select environments on engine launch by providing entry points through the command line as well as the configure menu of the sequence editor to specify the environment by a logical name. The Teststand deployment utility can easily detect environments in its directories for easy deployments. It's possible to easily deploy directories and configuration files this way. It's also possible to run 2 or more instances of the Teststand engine simultaneously in different environments. However, some features of Teststand, such as out-of-process synchronization objects, are shared by all running instances. Customizing engine settings for each environment. Now that we have discussed the purpose of Teststand environments and how to create them, we will now examine how you can customize the Teststand engine setting for each environment. The objective of this section is to identify which configuration files are necessary to include when deploying a test system. After creating a custom environment, each directory that was previously Teststand directory name will become environment directory name, and any directory not specified will map to the default location. The Teststand engine will store its various settings in the following directories: Common App Data, which has settings and data which can be unique across environments; Local App Data, where data and settings persisted in these files are maintained separately from those of environments specifying a different local app data. In the global environment, each Windows user account has its own local app data directory. When an environment specifies the local app data directory, all Windows user accounts share the specified directory. And the public directory, which specifies the Teststand public directory, which contains modifications and customizations to existing Teststand components, custom user components, and other Teststand-related files. Common App Data contains various Teststand configuration files, such as station globals, station options, and model plugin configurations. The Local App Data contains configuration files typically related to the layout and/or state of the sequence editor and Teststand user interfaces. And the public directory contains modifications and customizations to existing Teststand components, such as custom user interfaces and other Teststand-related files. In this demonstration, we will customize the Teststand engine settings for the Teststand environment that we created in the previous demonstration. In the Teststand sequence editor, navigate to the Types palette and review the contents of mytypes.ini. Now we will copy over a customized mytypes.ini to the mypublic directory that we configured for our previous environment. In the Teststand sequence editor, we'll navigate to Configure Environment. And in the Environment Path text box, we'll replace global with the absolute path to the myenvironment.tsenv file that was created in the previous demonstration. We'll click Set Engine Environment to load the new environment file. After Teststand relaunches, navigate back to the Types palette and review the contents of mytypes.ini. We will now find a custom demo step type under the step types container that wasn't there before. We can switch back to the global environment by again going to Configure Environment, selecting Global and hitting Set Engine Environment. And after Teststand relaunches now, we'll verify that mytypes.ini for the global environment does not contain the custom demo step type. When the time comes to deploy your test system, use the System Source tab of the Teststand Deployment utility to deploy your custom environment. If the target system also uses multiple environments, enable the option to use the environment file to determine deployed file destinations. This will ensure that Teststand deploys your configuration settings to the custom location specified in the environment file. This option also includes the environment in the deployment. Without this option enabled, Teststand deploys your settings to the global public, local app data, and common app data directories. Exercise 2.1. Create a custom Teststand environment. In this exercise, you will create a Teststand environment to store and maintain custom configuration settings for your test application. When you have finished with this exercise, please proceed to the next slide. Which directories have been defined in your environment file? The Common App Data directory and the Public directory. Your environment will use the global settings for the local app data. Creating Teststand environments to enable 2 or more Teststand system configurations to exist side by side on a single system. Configuring each environment to use a combination of global and local configuration settings. That there are 3 directories that contain the configuration files that you can customize for a given environment: public, local app data, and common app data. And when deploying a test application, you can specify which environment you want to deploy with that application.